So this one is going to be on ABO discrepancies.
Oh. Have y'all been getting a lot of gunshots in y'all's neighborhood?
My neighbor was shooting, but like he's shooting at the target in his backyard. So not so much like other people's.
I live over here in a residential area and somebody keeps shooting late at night.
Yeah, see, I live out in the country, so there's like my next door neighbor literally has like a little shooting area in his back 40. So discrepancies are when forward grouping doesn't agree with the reverse. Some of your potential causes is the agglutination is weaker than expected. So what's your expected agglutination reactions for ABO? For like your forward and reverse typing, what kind of reactions should you be getting?
Is that like the positive 1, 2?
So what numbers? 1, 2, 3, or 4?
For the reverse or forward?
Either, both.
1, 2, 3. Oh, why is it just 1 and 2?
Well, this is weaker. So what you should be getting is 3+ or 4+ reactions. So if the agglutination is weaker than expected, then you'd be getting like 1+ or 2+ reactions. When really for ABO, you should be getting 3 or 4+.
So then when you're doing the first part of this chart and you get a +1 or a +2, then that's a discrepancy?
It's something that you should be looking into. It could be as simple as the reagents not working the way it should be. But yeah, if you're getting a 1+ or 2+ on the forward and reverse typing, it should be a sign that there's something that you should check out. Now on like your antibody panels and screens, then it can be normal, but not for your ABO.
Okay, so it should either be a 0 or a 3 or 4+ when you do the anti-B and anti-A and A cell and B cell, right?
Correct.
Okay. Okay, then I did something wrong in the lab because I got like a.
Consider in your lab too that your reagents are not all within the date. So that is one of the things where if you're starting to get weaker reactions on your patients, that you need to look at your reagent first and see if it's close to its expiration date, or I'd hope in the lab it wouldn't be past its expiration date, but when it gets near the expiration date, that is a huge reason that it might start showing weaker reactions. And so in class, they're all generally expired or close to it.
Okay.
So that's pretty normal for class. Just as long as you know it's not normal for in the lab practicality. So another one would be expected reactions missing. So like on the homework, there was one where they forward type as A and reverse type as B. So if you forward type as A, you would expect the reverse type to type as A as well. And then your other option would be extra reactions noted. Okay, so some of your basic discrepancies, if the ones that involve problem with your red cells can be rouleau, and that can be due to a failure to wash cells, a mixture of cell types. So like if you had an A or B patient transfused with O cells, there's subgroups. So like A2 or A1. And so what you would do there is test for anti-A1 for the A subgroup. Unusual genotypes like Bombay, you can test with anti-H. And then if it lacks anti-H, the H antigen, then you know that they're probably Bombay. And the cells will not agglutinate with anti-H because the Bombay serum will agglutinate with A1 and B cells as well as group O screening cells. Disease process, so like leukemia or bacteria or the acquired B phenomenon, you just check the patient diagnosis, and the ID for it is beyond the scope of this review, meaning it's really hard to explain. Problems with the serum, you can have rouleau due to increased serum proteins, like Waldenstrom's or multiple myeloma, and then you just do a saline replacement technique. Room temperature or cold reacting antibody, so like HIMN or P1 or Lewis, and anti-A1 in A2 or A2B individual, so that reacts with their corresponding antigens on the reverse cells. You can do a mini cold screener panel. Age, what do we talk about as our two problem age ranges that'll cause weaker reactions?
What'd you say?
The two age ranges that'll cause weaker reactions.
The young and the old.
Old,
Yep.
young and old.
Young and old. So age, the elderly antibody production has decreased, or the newborn antibody production has not reached optimum levels, or they'll have missing antibodies. So newborns, they'll have either weak or partial antibodies. And then the old, again, they're decreased. So you might not see as strong of reactions. So you check the patient age, you can do a mini cold panel. And which one can you, for which age group can you heat it, incubate it longer to enhance the reaction?
Children. Not young children. Pregnant.
No?
Old people.
Old people. So the elderly, if you incubate it, you can help enhance the reaction sometimes. But the newborn, you can't
Yeah.
incubate the newborns and to enhance the reaction.
Yeah. I got it backwards.
That's okay. And then compromised immune system. So with your A hypogammaglobulinemia, you can check the patient diagnosis or do a mini cold panel. So with any ABO discrepancy, you must transfuse group O cells until the discrepancy is resolved. Why is that?
I don't know.
Because they're the universal donor. So what if they needed plasma and you had a discrepancy? What would you transfuse them with?
Would have to be O, wouldn't it?
For plasma?
Oh, for plasma. I don't know.
So for plasma, it's the opposite. So then they would need AB plasma.
AB. Okay.
And I just posted the copy of the second ABO video this morning. So the compatibilities and stuff are all on that one on YouTube. So here's a nice, it's like a smaller flow chart for ABO discrepancies. So if you're having an issue, a discrepancy forward typing, you can go down. It's either missing your weak antigen, extra antigens, or mixed field reaction. So most of the time, a mixed field is group O transfusions to a type A or B patient. Or, it could be in the case where someone messed up and the patient got the wrong blood type. And then a stem cell transplant. So if they've recently undergone a stem cell transplant, then that could be where you're getting your mixed field, or type A3 or B3 phenotype. Now, if they have extra antigens, that would be like your acquired B or intestinal disease, rouleau, or cold autoantibodies, and Wharton's jelly. Do y'all remember what Wharton's jelly is?
No.
That one's on my RH video too. I just forgot y'all haven't seen that one. So the Wharton's jelly is kind of what's attached to the baby when they come out, and it can contaminate like the umbilical cord specimen, and it can cause some issues with typing. Missing or weak antigens, so like an A or B subgroup, and disease like leukemia. So we've got extra antigens. We've got group A or acquired B. Group A with acquired B. So the group A sugar, immunodominant sugar, is altered by the D-acetylating enzyme. And again, I don't think it's so much important to know the mechanism behind it as it is to just know that it's a possibility. So group A. And I knew you'd ask. So D-acetylating, acetylating removes the acetyl group. And that is essential to gene regulation. So group A with acquired B, an acquired B antigen, you will forward type with your A like you normally would, but then you're also going to forward type with that anti-B with a weaker reaction than you would if they were type AB. And then your reverse grouping would look like your normal group A. So the difference between group A and then the acquired B is going to be a weaker reaction with the anti-sera for B, anti-B.
So the anti-B should have been 0.
Exactly. Yep. If they were just group A or normal group A.
Okay.
And then another extra antigen would be, example, would be polyagglutination, which is a hidden antigen on the red blood cells, becomes exposed. No spelling suggestions. My Word documents tell me that a lot. That my words are spelled wrong, but they have no suggestions for it. No, you just don't quite know it yet. So
You can add,
oh, sorry, go ahead.
you can add them into your word bank to where they accept them.
Oh, okay. So it reacts with most human sera, your polyagglutinated cells. Another issue would be rouleau. And what's rouleau?
Red blood cells stacked on top of each other like coins.
Exactly.
With
That coins is the general terminology used to describe it. And what this will do is cause a false, is it false negative or false positive?
false positive.
It is. It's going to be a false positive because if you think about it, rouleau looks like agglutination and acts like agglutination. So it's going to cause a false positive agglutination when it's really not supposed to be there, or what seems like agglutination. So abnormal amounts of what? What is rouleau associated with?
You should know this.
Starts with a P.
Give me a minute. I know this.
Protein.
Protein. Yep. So abnormal amounts of serum protein. Your resolution. How do you solve this issue? You repeat the test with saline wash cells.
Okay.
And all these I took out of my old book. It's Modern Blood Banking and Transfusion Practices by Denise Harming. But y'all don't have the same book, but I got all the results from that one. So your ABO discrepancy caused by rouleau formation is going to be, their type is AB, except for when they are forward typing, they get the correct reaction. And when they're reverse typing, they have weaker reactions. So no agglutination with A1 and B cells in the reverse type is due to rouleau formation as a result of increased serum protein or plasma abnormalities. So what should it normally be in the reverse? If you have a group AB person.
AB person, it should be 0.
0 and 0. So they're getting these weak 2+ reactions instead.
I forget my mic.
And another one is cord blood. What's cord blood? So your cord blood is going to be what they take from the umbilical cord when a baby's born, so like a newborn. And that can be contaminated with Wharton's jelly, which again is just like a substance that's like a mucousy substance. It's a jelly tissue in the cord blood of babies. Now it causes the red blood cells to aggregate. And like the rouleau, you can wash the cells. In this case, it would be 6 to 8 times. So in the rouleau, you would use a saline replacement, but for this one, you would wash them 6 to 8 times to get proper ABO forward typing. So why does this one include forward typing but not reverse typing?
Say that again. What did you say?
So you wash the cells 6 to 8 times to get a proper ABO forward typing. Why aren't we talking about reverse typing for cord blood?
Oh. It's because like infants don't exactly have what's that? Because we're talking about weak antibodies and all that.
Yep.
But
generally, any antibodies babies are born with are going to be mom, and so they develop around 4 to 6 months. So generally for newborns, they just forward type them because the reverse type is just going to type like mom. Then our next one's going to be missing or weak antigen. So you can have ABO subgroups. And you repeat with anti-AB or anti-A1.
You're back up to potential causes.
I am. Let me go back down. Can you see it now? Missing or weak antigens.
Can you?
Let me reshare it. Can you see it now?
Yes. Yes. Okay. Sorry.
That's okay. So missing or weak antigens, you got ABO subgroups. For those, you can repeat with anti-AB or anti-A1. And what is the other term for anti-A1? It's anti-A1 or anti-A1 what? your anti-A1 lectin. So they call it either anti-A1 or anti-A1 lectin. You've got disease states that can cause weakened expression. These include but are not limited to. There are other ones, but you've got Hodgkin or leukemia. And you can try incubating it for 30 minutes, 30, not 20, 30 minutes to increase reactivity. I told you, no dying during my videos. You have to wait till after. So you can try incubating for 30 minutes to increase reactivity. And what was the other one? Was it young or old that you can try that to help?
Old.
Old. Yep. So leukemia reaction.
Old.
Old. Yep. So in the case of leukemia, you've got for, if you have a person who's A, you might get a mixed field reaction for anti-A, and then a negative reaction for B, and then a negative reaction for A1, and then a positive reaction for B. So if you were type A, what would you normally have?
Would be it would be positive 3.
It'd be 3+ or 4+ for anti-A, negative for anti-B, and then your A1 and B are correct for type A. And then again, for your B, your reverse grouping is correct to type as a group B. But then it's your forward grouping that has the issue, and that's due to weakened expression of the antigen due to leukemia messing up the cells.
So what is that plus MF again?
Mixed field. And I showed y'all a mixed field reaction for the gel. Let me see. Just a second. I can show one for. Can y'all see it?
Now I can.
Oh, no, that's one. So here's some of your mixed field reactions.
Cool. Okay. And that could be due to
Leukemia is
the
one of the
disease,
reasons.
or could it be due to
it can be due to leukemia. It can be due to like someone who's type A or B getting type O cells, or any kind of someone not getting the exact identical match of their cell type. But in this case, in the case of leukemia, it's due to it messes with the forward and not reverse, because it's messing, the leukemia affects the antigens on the red blood cell, on the surface of the red blood cell. Oh, and then put a note here, mixed field just means that you have agglutinated and unagglutinated cells. Which is caused by two distinct cell populations. Let me put this as like a separate. So it's caused by two distinct cell populations. Example would be group O blood transfused to group A individual. Bone marrow or stem cell transplant. It can be due to an A3 phenotype. In which case you would get mixed field with anti-A1. And with anti-AB. Again, I think if you got asked about one, it wouldn't necessarily be like an A3 phenotype. It's not that common. But if you did, you would have mixed field with anti-A1 and anti-AB. Then you've got your TN polyagglutinable red blood cells, and that is an acquired disorder. And it's caused by a mutation.
Can you go back up a minute?
Yep, is it not back, like up here? Or how far up?
No, go back. I'm doing the mixed. Go down a little, right there, and give me just a minute, sorry. So while y'all are waiting on me, I have a question.
Okay.
On the test that we previously took, there was a question that the kids, what if they don't, on that Putin square,
Mm-hmm.
what if they don't give you the mother and the father? But let's say that they have 4 kids, and each of them, one has A, one has B, one is AB, and one is O. Would that mean that the parents are ABOO? Or am I completely wrong?
I don't think you can't have children that are AB and children that are OO. So you can't have a group,
Well,
like no matter what, you can't have one child that is group AB and one child that is group O without stepping out of that relationship bound, if you catch my meaning. Daddy's not the daddy if you have 2 kids and one's AB and one's OO.
Because I don't think it had, I don't know, Lil, did it have an option for that? You remember that one on the test? Said they had 4 kids,
They didn't
and
put
one was
moms a hoe as an
A,
option. How
one
dare
was
they?
B,
Oh
one was
yeah.
O.
It was like if that type and that type, because there's like 3 or 2 questions I think about that. But which one?
It was the one where it told you what the parent, they had like 4 kids, and one
Mhm.
was A, one was B, one was O, and one was AB. What did the parents phenotype as? And it didn't give you an option that they were not. It just gave you an option of either AO, BO, AB, OO, or
So you can find it out. You can find it out without being told the parents, just if you know all the kids. But they just couldn't be.
I'll have to think about it because I don't remember.
Yeah, you'd have to
I
tell me
don't
like.
remember that one.
Because I only remember the one where these 2 parents are together. What type of kids are going to have AO, AB, something like that?
So if instead they gave you that the kids are, let's see, AA, AO, and OO. Nope, that won't work. That one. So then you could go in and say, okay, then for this kid, mom has an A, and you know dad has an A because they got it from both. And then for this kid, again, you know mom's got an A and dad's got an A. And then for this one, you know someone has to have an A and someone has to have an O. So mom's got an A already, so she could have given the A, or she can give the O. And then for this one, AO, again, like dad's got an A, so you'd have to give, the other one would have to give the O. So you'd have 2 heterozygous group A parents. Or if you have, let's see, AO, oh, yep, you can have AO. Let's say you have AA.
So you can't have an O with an AB.
You can't have AB in a group O.
Parent is AB.
What? See, because if you had like, let's say one AB parent, and then let's see what your O would be. So your choices would be AO. Oh, I guess you could AO, and then you would get BO, and then you would get your AO and BO. So these would be, if you had these parents, a group AB and then a group O, you would get either 50% of them are group A and 50% are group B. and they're all heterozygous, but you couldn't get a group O child out of it. But you could have a group O parent.
So maybe that question was wrong then.
I'd have to read it before I would say whether it was like wrong.
All right, I may look that up and
Yeah, you
'cause I
can
think
text
I
me a picture
wrote
of it
it
later.
down somewhere.
If you text, yeah, if you send me a picture or
Okay.
something of it later, then I can send it to you. But the way you would figure that out is just do it backwards. So instead of doing it this way and having so instead of doing it out like that, they would just give you the children. And then you can say, okay, well, I have to get one from mom and one from dad out of every one. So mom and dad have to have an A or an O. So one has to have an A, and one has to have an O. And then for this one has to have an A, one has to have an O. And then for this one has to have a B and one has to have an O. So you can either have BO or your other choice would be, I think you could also do AO and BO.
Yeah, see, the question
But if it
said
was 50%,
that they had 4 children.
so the other way these would type out would be, let's see, AO and BO. So this one would be AB, AO, O, OO. So you could have these results. You could have an AO or a BO that comes out with AO and BO children. But if you are between these two, which one are you going to choose for? If 50% are AO and 50% are BO, would you choose the AB and the OO, or would you choose the AO and the BO?
Would it be ABOO?
Just like me do it out for you so you can see it a little easier. So both, let's say they're asking if you can have an AO and a BO children, then these are the two possibilities for their parents to have. But if they were like 50% are AO and 50% are BO, then it would have to be this one here, because only an AB and an OO parent can have 50-50, whereas an AB or an AO and a BO parent would have 50% or 25% AO, 25% BO, 25% AB, and then 25% group O.
So the parents who are AO and BO have an AB child, an O child, B child, and an A child.
Correct.
Blood type.
Yes.
So that's why I got it wrong. I put ABOO when it should have been BOAO.
Yes. So you can do them. It's just backward when you have to find out the parents. But watch out whether it says whether you can have that or whether it's 50% or 25%, because those percentages can more define the parent. I hope I explained that somewhat well. but like you can have possibilities, but if it's saying like 50% compared to 25% or you know, along those lines, then it narrows your results more.
Yeah, it didn't give a percentage. It just told you what the children were,
Okay.
and it wanted you to know what the parents' blood group was.
Uh-huh.
So if they had one child that was O, one child that was A, one child which is B, one child is AB, then it would be the mother AO had BO.
I think I'm sorry, I wasn't listening enough. What was, one more time? Yeah, depending on whatever the results
Okay.
are,
So,
you just do it backwards.
well, but they didn't give you the parents. They gave you the kids.
Uh-huh. Then you
The
just do it
kids
backwards.
were A. So if the kids are A, B, O, and AB, then the parents would have to be AO and BO.
Yeah, so they'd have AB, BO, AO, and OO. If you had an AB and an, or I'm sorry, an AO and a BO parent, you'd get AB, type O, and then you'd get AO and BO. So you could have an AB, an O, a group A, and a group B child. And in that case, you'd
Okay.
have parents that are AO.
All right, that makes
and BO.
sense. That threw me off.
Yeah, you just kind of have to remember that you have to get one from each parent. So each like AB or AO has to correspond with each parent's ability to give one of the genes. So you can't have
Okay.
any kind of heterozygous child with an AA parent, or you can't have a homozygous O child with a parent that has AA or BB or AB, because there would be no one to give an O. And definitely not
Even if the
homozygous.
dad was O,
Yep, if you don't have some sort of
what if
heterozygous,
the mom was A?
if mom was what?
If mom was AB and dad was OO, you couldn't get a child with AB because the father doesn't have any AB,
You
A
can
or
get
A or B.
you cannot with a mom or dad that's AB and then group O, you cannot get a AB child and you cannot get a group O child. Because your group O, you can get heterozygous group A and you can get heterozygous group B, but you cannot get a homozygous group O child. And you can also
Okay.
not get an AB child because the other parent doesn't have an A or a B to offer.
Okay. That makes sense. Okay.
So in that case, you would get 50% AO heterozygous for A, and then you get 50% heterozygous for B. So they could go on and have a child that is group O, but they would not be able to make, it wouldn't be till their grandchildren. And then it's still a possibility.
Okay.
So extra antibodies. We talked about missing or weak antigens and extra antigen. Now these are extra antibodies. They occur as extra agglutination reactions. And so where is that going to take place? Your forward or reverse testing?
Reverse.
If we're talking about extra antibodies.
Reverse.
Exactly. So it's going to occur as extra agglutination reactions in reverse testing, because your reverse testing is looking for patient antibodies, whereas forward testing is looking for patient antigens on their red blood cells compared to the antibodies in their plasma or serum. We've got causes. They can be anti-A1, or they can be cold autoantibodies. So you've got autologous antigens, autologous antigens react at room temperature or below. And then you would perform a cold panel. And a lot of these make more sense when you're in the lab doing it. And then you can do a cold panel and auto absorption. Or a rest test. Or you can reverse type it. At 37 degrees Celsius. And find out if it's a possible auto, and I'm going to put a picture, don't worry, auto anti-I. And then specific human red blood cell antigens. React at room temperature or below. And again, you can do a cold panel or rest. Oh, and sorry, I didn't put it up here. Rest is rabbit, erythrocyte, stroma test. And then the other thing you could do is perform an antibody screen with an auto control. Now this one's specifically a mini cold panel, or you can do a bigger one. So it's used to enhance serum anti-A and anti-B reactions when they are expected but are not demonstratable using room temperature readings, and identify the cold antibodies reacting with other antigens on A1 and B reagent red cells. So it's pretty much saying if it's not working the way it normally does at room temperature, this is your cold panel. So your patient serum tested with A or B cells. If it's positive, it can be anti-I or an unexpected antibody reacting at a colder temperature, or it can be your anti-A or anti-B. But if you're, when you have your patient serum tested against group O cells and it's positive, it can be anti-I or an unexpected antibody. But if it's negative, then it's going to be an anti-A or anti-B. And then if you have group O cord cells available, these are going to be your results for that. And then your auto control, if it's positive, is going to be anti-I, which is an antibody that we'll learn about this next week. And then if your autocontrol is negative, then it's probably an unexpected antibody reacting at a colder temperature, or anti-A or anti-B. So your difference with your A and B cells, if you're getting a positive and a negative autocontrol, it's anti-A or anti-B. And then if you're getting positive with A and B cells and a positive autocontrol, it's anti-I. Is the main things to take away from that. And again, the cold panel is just a little more advanced, and you would learn it if you were working in blood bank. Everyone good so far?
Yeah.
That one was the one where I'm like, kind of a lot to take in at one sitting. A lot of big words that are like. So our next one is missing or weak antibodies. Okay, so here's a good, so we talked about newborns and elderly both causing weak reactions. So which one would be weak antigens? Missing or weak antigens? Newborn or elderly?
Elderly.
Newborn.
Newborn, yep. And so which one would be missing or weak antibodies?
The elderly.
Elderly. So your missing or weak antibodies will come up as either weak or negative. And so is that going to be in the forward or reverse space?
Reverse.
Reverse. Yep, because we're talking about antibodies right now. So if we were talking about weak or missing antigens, then we'd talk about in forward. So that's how you can kind of narrow it down too. If you're looking at a set of results and it's asking you what the issue is, you can start off by knowing, okay, is this an issue with forward typing or is this an issue in reverse typing? And once you figure that out, then you can say, okay, this has to do with missing or weak antibodies or extra antibodies or you know, you can figure out your reaction there and then think about, okay, which ones are in that group. So elderly have reduced antibodies, and newborns often have missing antibodies. So before less than 4 to 6 months, mostly maternal antibodies. So in this case, you would get all negative reactions. So that would be for anti-A, anti-B, A1, B, and your AC, which is your auto control. So they're all, if you get all negative reactions, what might that lean you toward? And we're talking about weak antibodies, so we know the problem's going to be in the reverse typing. So what if you get all negative forward typing? What would that normally type as?
Wouldn't that be O?
Yep, so that would be a group O. But then we have a discrepancy with our reverse typing. So it would be group O.
That's for forward.
Yep. We put in my last little comment so it's not below the picture, and then I'll insert my picture. So there's also some disease states with decreased immunoglobulin levels.
So the group O, young and old patients with weak expressions, that's with the forward.
I will show you on the picture here in just a minute, and I think it'll make a little more sense than just speaking. But let me put in this one real quick. So disease states with decreased IG levels. And what's IG? Your IG here, what does that mean?
Hemoglobin.
Yep, immunoglobulins. Okay, so your ABO discrepancy seen with weak or missing antibodies. So your forward type, this would be like a group O elderly or young patient. And so you would forward type normal. So negative for anti-A, negative for anti-B. And then your reverse grouping, you get negative again. And if you had group O, so in a normal patient, those would both be positive. But they're negative due to the main reasons being either older patients aren't, they have reduced antibodies, or your newborns have missing antibodies because they're all maternal at that point until about 4 to 6 months of age. And then same for when we talked about your weak or missing antigens. It's also an issue then because the again, it'll be the reverse grouping for your elderly and then the forward group or the reverse grouping for the newborns, but it's going to be due to the antigens on their red blood cells not being as formed. And then the elderly is due to the reduced antibodies.
So it's basically the same on the reverse and forward.
Yeah, you get the same results. It's just the reasoning behind it that's different.
And what was the reasoning again behind it? Your
elderly have reduced antibodies, and then your like with age, and then your newborns don't have prominent they have their mommy's antibodies.
They don't have.
And a lot of times
Right,
newborns can have a weak expression on their antigens of their red cells too.
Okay.
And I know y'all are probably getting sick of this one, hearing about it, but I guarantee you she has or will ask about it on a test. So your Bombay phenotype. What does that look like? What's another nomenclature for that? Or your genotype for it in regards to H's?
Little h, little h?
Little h, little h. Yep.
No? Okay.
So does it have H or lack H?
Black.
Yep, lacks the H antigen. The first reported case was in Bombay, India. Now they generally type as group O. Which and it's like, if you think about it, it makes sense because they have no H, no A, and no B antigen. And you're not really testing for H, you're testing for A and B under the assumption that if you don't have either one of those, you're group O. But their serum contains anti-H. What else does it contain? So they have no H, no A, and no B antigens. So what do they have antibodies to?
O.
A
Well,
and
your
B.
O is going to be your H.
Oh, wait. Was it D? So anti-D. So A and B antibodies, I guess.
So they'll have anti-A, and then they'll have anti-B. Just remember the law, Landsteiner's law, is your body will make antibodies to anything that your red cell is lacking antigen wise. So if you don't have H, A, or B antigens on your red cells, then you'll make antibodies to them.
Right. Okay.
And then the relation to Bombay and transfusion. Can you give group O?
I don't
Can you
think
give
so.
group O blood to a Bombay person?
No.
No.
It has to be just people with Bombay.
Exactly. You cannot give group O cells to, I'll leave it at that. You cannot give group O cells to a Bombay phenotype. And only have Bombay with no H antigen present. Remember when we looked at that little H chart? Oh.
Right.
Yeah, so when we looked at this, you've got your precursor H, and so this is your Bombay. So they've got little h, and they don't have this H. But the reason that group O is a universal donor is because normally you've got A and H, then you've got B and H, and then you've got O, which is just H. But you can't build those A and B antigens without having that that fucosal sugar, which is your H specificity, as a base. And so if you just have O, then you just have
Right.
H. But the Bombay doesn't have that. So if you give them group O, they still have this H antigen that they do not have. So it'd be the same as giving someone who is like O, like AB blood or A blood or B blood. You can't give them an blood with antigens that they don't have. Oh, and then so they can only have Bombay blood. So what are your 2 options to get Bombay blood from?
Themselves?
Exactly. Yep. And what's that called?
Auto. Oh, you got it. Autologous.
Yep.
Okay.
So they can either donate for themselves if they know they're going to have some kind of surgery or something, or they have to have another Bombay donor, and they have registries for these. And then that's all I have on the discrepancies. And now I was gonna do Kel next. Give me just a moment. Let me stop them.